All right. So first of all, those who are new here or joining us for the first time on this group, here's a chance to just see the organizers of this group. It includes myself. I am a senior architect at Avia Consulting, and along with me, Sandeep is here, who is also a co-lead for the America region. Sandeep, you want to introduce yourself?
Yeah. Hey everyone, I'm Sandeep Deshmukh. I'm part of the MuleSoft's customer success team working as a technical architect. Been with the community for past 4 years, even before I joined MuleSoft, and I'm glad to be here. Nice to meet you, everyone.
Thank you, Sandeep. And in addition to us, we have Royston and Angel who handles EMEA and APAC regions. So since it's America region here, you will see me and Sandeep being your host. Some guidelines, please use chat for any discussions during the presentation. Sandeep is gonna enable the Q&A tab, so please feel free to add your questions there and we will try to answer them as we go through the presentation or towards the end of the presentation. But we will try to answer as many as questions that we can. Recording of this event will be shared. Usually it comes out within 24 hours after the event and you should be able to see it on the event page. So just go back to event page if you want to catch up on anything and you will see it. Your feedback is very valuable to us. At the end of the event, the platform usually send out and survey emails. We would love to know what you think about all these events. What are your thoughts? So please consider filling any surveys that you will receive towards the end of this session. Thank you. So some announcement. This is the one that I was talking about. Today's session is part of the Dreamforce 2022 tour. So what that means is there are certain community presentations that happened at the Dreamforce, and we are going to redo all those sessions on different meetup groups. So you can scan that barcode and take a look at all the sessions happening across the meetup groups for MuleSoft. The next, this is very exciting, and EMEA Community Conference is coming up. It's on the November 16th and 17th. I definitely suggest you scan that one and take a look at the agenda. There are a lot of sessions that are included in that conference, and you will see a good diversity of topics, speakers, and everything in there. And they're going to happen in multiple languages like English, French, Italian, Spanish, and across the time zones. So I definitely suggest you all to check that out. And if you cannot find anything about it, feel free to reach out to anybody in community and they'll be able to help you out to find it. Before we get into the today's presentation, if you haven't joined anything MuleSoft community, you could join it using the QR codes on the screen. First one, please consider joining the MuleSoft community LinkedIn group there and find your local meetup group and feel free to join that. That will help you to connect with the community and reach out to more people. Okay, with that, I think it's time for a presentation. I'm going to switch my screen. Okay, this goes out. Ah, okay. In 10 seconds, you should see it again. There you go. Do you guys see screen okay?
Yes, we do.
Okay, cool. So let's begin. Today's topic is architecting integrations for observability. Right. Myself, Manik Magar. I think I already introduced myself, so I'm not gonna do it again, and we'll just continue with it. Right. Safe harbor. Just consider what is available right now in the market, and then decide what you want to do. Not based on anything, any forward-looking statements that I may make in this one. So it's just for a safeguarding.
Hey, Manik,
Um, yes.
your slides stopped showing up. I can't see them anymore. Uh,
Uh,
is
is it?
everybody else able to see the slides, or is it just me?
I think it may be you because I see people saying they can
Okay,
see it.
yeah, some are able to see. Okay, carry on. I
Okay.
can.
Okay. Okay. No, thank you. So there may be lag, so I'll just slow down a little bit when moving between the slides, and hopefully that will be better. So this is again me. I will get past me so you can hear good things. So today's agenda. Today we will look at a digital transformation story of a retail store and learn what they are doing. Right, basically what they are doing for their digital journey. Then we will look into observability, what observability is, and what are its pillars. And then at the end, we will learn about how to design our integrations for observability. And at the end, we will look at the question answers. So, what's the story for us today? We have a retail store in our neighborhood with a few stores in nearby localities, right? So as a brick and mortar store, they were doing well, but as everything started going online, they soon realized the need for online presence and opportunities to expand their business. Soon they started working on their digital transformation journey. So one of the initial goals was online ordering system. Since they were all offline, the very first thing, okay, let's start accepting orders online and expand our business, right? So they analyzed their existing digital footprint. Some building blocks for this transformation already existed, and based on that finding, they decided to take a mixed approach for their digital evolution. What that approach looked like. So the very first thing, they decided to create new APIs by using the new technology advancements and new platforms, the platforms that will allow them to securely provide user experiences and shorten the time to market for their new APIs. But you cannot create everything from new or everything from scratch when you are migrating, right? So obviously the next thing was, let's reuse some of the legacy APIs, at least for the initial phases, right? So that was another point that they did. Lastly, few critical APIs needed to be migrated, and that is for different reasons. Because as we are expanding into online world, it is going to bring in more volume to our systems. We needed to scale for all that volume, right? So all those critical APIs we chose to migrate into new platform. So if we take an example of our online ordering use case and put that into API led, how would that look like? So it would look like something like this, right? So we have an order experience API, and which is going into the order process API, which is consuming three of our system APIs. So as you see on the screen, there are two APIs. Basically, the experience layer and the process layer is what we created as a new APIs. Order API and inventory APIs, which are system APIs, we migrated them into new platform. At the same time, the legacy shipment API, we decided we will just reuse the same API and continue with it, right? So that's how our API led approach would look like. So when we went live, we were excited to see how this new experience is gonna look like, right? And when we when orders started trickling in, we were pretty happy because everything seems to be working well. We were receiving orders, we were creating shipments, inventory APIs was working very well. But after some time, things started to change. One fine evening, what happened, users started seeing slowness in order submission, and eventually the system started going down, right? And it's probably everyone have seen these kind of things. Support team was continuously turning different systems, different logs. They were trying to understand what happened, what went wrong, right? They saw timeouts from the order experience API. They saw error stack traces in the log files. They were looking at the monitoring dashboards to understand if there are any CPU issues or anything, right? So basically reach out to every resource to understand what is happening. I'm sure some of you may be able to relate to this story of an evening. It may have happened, if not everyone's, but in most of us work life. But what happens due to the downtime? So any downtime, whether it's planned or unplanned, cost the business. In Forrester report, the real cost of planned and unplanned downtime, IT leaders indicated the costliest aspects of the downtime. And what they say, like 53% of the IT leaders said downtime results in lost revenue. So revenue is lost because of that. 47% of the IT leaders tied loss in productivity to the downtime. And lastly, the 41% of the IT leaders agreed to the loss of brand equity or trust that happens due to the downtime. So longer the systems are down, larger is going to be the impact. And if downtimes is bad, what can we do to lessen that impact? How we can minimize that impact? So the question comes to us is, how do we debug our system incidents? Like what should we do when system incident happens? Right? The very first approach is traditional approach, which is monitoring and metrics based. It is very reactive debugging approach, and I say reactive because it depends on you requiring to set up predefined metrics or alerts for known error conditions. For example, oh, we have seen CPU going past certain threshold, and that's when we saw error, so we will set up a monitoring for that threshold, right? So everything is based on certain assumptions that we have seen in the system. And that's the reason it is reactive. But can we change our approach? Like, can we capture as much data dimension as possible and then introspect that data for any possible error scenarios instead of predefining any of those situations? And this is where the observable systems comes into picture. It is kind of predictive debugging approach because you can capture as many data dimensions as you need without knowing without any assumptions about them. Since you have all that data available, you can ask questions about your system states and investigate what has happened throughout your system, understand and explain the system states without shipping any new code because you are capturing data continuously. Now, if we don't need to ship any data and still understand the system state, what does it call? I think that is what is called observability. You are ready to observe your systems without intercepting them, right? So observability is a measure of how well internal states of a system can be inferred from knowledge of its external outputs. That's the definition, right? For software systems, it is an ability to understand and explain the internal state of a system by using external data such as logs, traces, metrics, any health check data, monitoring, basically you can look whatever you can observe from outside. That is what you will use, right? So let's learn little more about each of those components and understand how to include those into our integrations. What are some basic pillars of observability? The very first pillar is logs, right? And we all are aware of logs. We are using logs almost everywhere, so we know what log is. But by definition, a log is an immutable and time-stamped record of a system event. Logs can be of many formats, structured or unstructured. While like unstructured logs are easy to add, for example, a simple text logging saying, "Oh, something happened," right? That is a kind of an unstructured log. But if we go towards the structured logs, they do enable a lot of features into our system. They are easy to process. They are easy to aggregate, report, and generate alerts based on certain data points in there, right? So the default logger can provide unstructured logging capabilities in Mule, but there are other options that are available. And one of those options is an open source module, Mule Custom Logger, that is available for us to use. If we use that one, this is just an example of how it will look like when you drop Mule Custom Logger processor in your flows. But what does it look like, the data? So this is how it looks like. Once you configure and get your log, the log entry is no longer a simple string statement. It is a pretty good JSON structure or any structure that you want. It is a structured entry which you can easily process and then identify any issues or anything from it. Next is metrics. We have seen metrics in Anypoint platform and all other open source tools. But what is a metric? A metric is a single numeric value, optionally with tags appended for grouping and searching. And we often aggregate these metrics over a period of time so that we can visualize this data into a dashboard that how it is looking over the period of time, right? We can use these metrics data to create alerts, to trigger alerts if certain threshold is met, like if CPU hits 90%, send out an alert. If memory goes to 80%, send out an alert. All these can be done based on the metrics. For metrics part, it is easy because Anypoint monitoring and runtime manager supports capturing metrics and reporting dashboards as well as your alerts. So we have seen Anypoint monitoring where you can see all the CPU usage, memory usage, and lot of other metrics data reported from your runtime. This is just an example of how the response time will look like on the dashboard, right? So you can use Anypoint monitoring for response time response time metrics. The next one, the third pillar is traces. What is a trace? A trace is a representation of interrelated distributed events that describes the end-to-end request flow through a distributed system. That's the definition. In simple word, it will tell you how your request how your request got processed throughout your whole flow, what every system did and how they responded to it. It will give you an end-to-end visibility into that request processing, right? And because of that, it helps us the interdependencies of the services. When requests hop from one service to another service, all these traces can help us join those connections and see the service dependencies. Lastly, the traces can capture the data attributes related to your request, service, and environment. So if you are talking about the HTTP requester, you can think of like in getting the URL path or the query parameters, anything from that HTTP request component, and putting that into your trace, right? So this is just an example of trace visualization from Elastic. How will it look like when you start visualizing your traces? And it's pretty easy from there to see. Oh, you received a call on HTTP API endpoint, and then all that thing happened at the end. First flow send out on the order processing queue, which again got processed in there, right? So all of that can be seen from the traces. But trace visualization requires some additional things. It requires an application performance monitoring tools and APM tools such as Elastic APM, Splunk, Dynatrace, or any other commercial and open source tools. Now the problem is most of these APMs have their own proprietary trace data formats, which means if you start integrating with the proprietary trace data formats, you are binding your system with a certain format, right? Which we all know is not a good idea. So fortunately, there is a project that provides us a standard data format and specification to capture all these traces and any telemetry data. That is an OpenTelemetry. OpenTelemetry is a CNCF incubating project. It is it is basically a set of APIs, SDKs, toolings, and integrations that are designed for the creation and management of telemetry data such as traces, metrics, and logs. That is a definition. You can find it on opentelemetry.io/docs, right? But in general, what does that mean? What OpenTelemetry provides us is it provides a vendor agnostic instrumentation for support for doing an automatic as well as manual instrumentation of any system, right? It provides an open standard for semantic conventions for vendor agnostic data collection. So when we are exporting our data, we are not talking in terms of a specific APM format. We are talking a general data format. And if the vendors such as Elastic, Splunk, or Jaeger or Prometheus, all of these APMs, if they are compatible with OpenTelemetry, you should be able to send your data to any of these systems, right? And since you are not tied directly to those systems, your systems are independent of the vendors. So now, how do we implement OpenTelemetry for Mule integrations? So let me show you this thing. So Avio's OpenTelemetry module for MuleSoft. It is again an open source custom module developed by Avio for Mule applications. It is compliant with the OpenTelemetry semantic attribute conventions, which means all the data it exports is in line with the standards defined by OpenTelemetry, right? And because of that, it will be ingestible by any of the OpenTelemetry compatible APM tools. It does support OTLP as well as other exporters, which means if you are using, let's say, Zipkin, you should be able to configure a Zipkin exporter in there and start sending your trace data to Zipkin. The trace context propagation for distributed transaction, which is important because when our request is moving from experience API to process API and into the system API, we do want to propagate the trace context so that the APM can tie back all those individual spans from systems and show us an end-to-end view of how what happened right from the experience API until the last system in our flow, which could be in any system API or database or any third party API destination, right? In addition to that, it does have like a Cloud Hub aware Mule resource provider. What that means is if you deploy this application with this module in Cloud Hub, then along with the standard data, you will also see Cloud Hub specific information like what runtime version you are running on, what region you are on, application name, and all that stuff. So that's helpful to know about the environment of your application. And that module is available open source. That's the link. If you go to github.com or your consulting Mule Open Telemetry module, you should see it there. So now that was tracing, right? Like we looked at logs, we looked at metrics, we looked at traces, and then lastly, it is synthetic monitoring. What does synthetic monitoring is? Synthetic monitoring tracks the availability and health of a required services and endpoints. It can generate alerts when services are either unhealthy or down. Like what that gives you, like anything that you can identify sooner will definitely going to help you to reduce the impact of the downtime, to shorten the downtime, right? For Mule application, it can be as simple as adding health endpoints in your application that can extract the JVM stats or the system connectivity information. Anything that applies to your applications health, you can export all that data as a part of your health check endpoints. So on right hand side, it's just an example from Elastic's uptime monitoring where 4 systems are being monitored for uptime, right? And if you drill down, you will be able to see like more information, basically everything that you extract as a part of your health check. You'll be able to see all of that. So these are the four pillars of observability. But what do we need to prepare for this observability, right? Like we looked at all those 4 things: logs, metrics, dashboard, logs, metrics, traces, and synthetic monitoring in there. So let's see what kind of questions we should ask for us so that we can start designing for this observability, right? Do we have right tools in our DevOps toolkit to support observability? The first for the logs is log aggregation tool. Do we have a tool that can aggregate our logs, the structured logs, so that we can query them, we can generate report and analyze them? There are many options available. You can use elk stack, sumo logic, logic monitor, and many more, right? So that's for the logs. When we talk about metrics, there are probably like hundreds of data points that you can capture metrics for, right? excuse me. So CPU usage, request count, response time, or anything that you can think of for your system information, right? Some are system related and some application related. Give me 1 second, sorry. Sorry, needed a water a little bit. So there are a lot of data points for metrics, but do you have a tool to gather all these metrics data from your environment? And if you have to add a new dimension into that matrix, how easy or difficult it is to gather metrics for that new dimension? Those are some questions that you should ask for metrics. The dashboard is pretty easy because dashboards, there are so many solutions available for dashboards, and we need dashboards for visualizing our matrix data, visualizing our synthetic monitoring in data, and see if we can integrate that with alert mechanism so we can generate the alerts, right? So do we have any such tool in our toolkit that we can use? Lastly, for tracing comes into like two parts, like I said. One is capturing your telemetry data from application and environments, and the second is actually rendering that telemetry data in a meaningful human readable format, which is where the APM tools comes into picture. So the question would be, do we have an APM tool that can ingest our traces, preferably in open telemetry data format? And if it is there, does it have an integration with log aggregation tool as well, so that we can try to tie everything together and see an holistic picture of all the data points, right? So now we looked at all those four things and looked at the questions. How do we design for it, really? So with all these questions and all this information, what happened, our customers needed to implement end-to-end observability for their solutions. So we worked on this opportunity to help them implement. But as we implemented all of this thing, it led us to design an observability package for MuleSoft. And the reason for mentioning it here is all this learning was put into this thing so we can define how to design your integrations with observability in mind, right? Like this learning this learning and experience from our implementations helped us to make it easy to evaluate and take actions on observability data. We even made some of these components open source, although it is a good starting point. Like most of these tools, open source projects, you can just use and start with it. But building a full observability system needs little more than just those components, right? Like, so with that, how do we design integrations for our observability pillars? Let's take a look at it. So how would your integrations with this pillar may look like? Think of all those four data points: matrix, traces, structure logs, your synthetic monitoring, and all those fours. There are different ways of designing this problem, right? There is not just one solution for it. You can design same thing different ways, but one of the way could be this, right? So what do we see here? We have a mule application running in mule runtime, and we can see that mule application and mule runtime togetherly is exporting certain data set. The very first thing is a matrix. Runtime monitoring agent out of the box from mule runtime can export a lot of data about your mule runtime. So all that data goes into any point control plane, and you can visualize all of that using the anypoint monitoring or even runtime manager dashboards for your application. So that takes care of your metrics. For traces, we can add in Mule Open Telemetry module in your application and then start exporting all those traces to choice of your APM. Let's, for example, here it is Elastic Cloud, right? So I'm exporting all those traces into APM. Thirdly, for logs, since we are talking about Elastic Cloud as an example here, we would want to send that all those logs into Elasticsearch. So eventually we can tie back all our trace data and logs data together. right? So what we can do is we are shipping all our logs using the SQS appender, and then eventually it is going into Elasticsearch. So that takes care of our logs data. And obviously we are using the Mule custom logger, so we can generate a JSON structure of the logs that we can process in Elasticsearch and index all that data. Lastly, lastly we add an health check endpoints into our Mule API, Mule application, that we can hook into Elasticsearch again using the heartbeat monitoring, and all that data gets into the Elastic. So that way we have now all the data points, all the data attributes about our application: metrics, traces, logs, and health check. Now the last thing comes is users and their dashboards. There are options available, right? If we are talking about the Elastic, you can easily use Kibana to see the different reports generated out of Elasticsearch data. Yeah. We also have any point monitoring that can be leveraged for the metrics dashboard, right? So with all these data points in place, next time when system fails, what happens? Something like this should happen when system fails, when a request fails. And if you go on to your APM to look at your trace data, it should show you, oh yeah, we received a request on slash API, all those things happen. But if we look at the trace, we see inventory system API, there was an error on it. And if we correlate those traces and logs together, we should be able to click on the logs tab and take a look at the corresponding logs for this particular request, right? All these things depend on, these are UI features, and they do depend on the APM of your choice. But in general, most of the APMs should be able to correlate traces with logs, making it easy for you to go through, navigate through all your data points in there, right? So next time when system goes down, hopefully it should take less time for that support person sitting in chair late night, alone, trying to figure out what happened, and he'll be thankful to you giving all these tools to him. So I hope you found all these things useful and ready to go and try for it. So with that, I think next is thank you. So that's all I had. Are there any questions you guys have?
Hey,
Oh, yeah,
Manik, we have a couple of questions.
sure, go ahead, please.
Yeah, I think most of it is a couple of them were around performance. How would the file beats on log files to introspect the errors in the log would impact the performance? And I think same for enabling logs in trace mode. What would the impact in production would be?
So the first question about the file beat on log file, how would file beat on log files to introspect the errors in the logs would impact the performance? File beats is outside of your application, right? Like it's not, Filebeats is not part of your application. It is externally processing the log files that are already generated by the application. So it should not affect any of your application processing. When I say that, I mean the request processing, right? Because it is not interfering in that one. It is externally doing all of that process, right? So that I don't think it should, it would impact any of your application request processing in there. The second thing, enabling log in trace mode for production APIs would have impact on the performance. Yes, just like any monitoring tool, there will be an impact on your application. And if you go to the if you go to the I'm trying to get you a link. If you go to the modules GitHub repository and take a look at the documentation, it does include the performance report of using this module in your application, right? So there is going to be a standard impact on your performance. For example, if you enable monitoring, it's up to like 5% of your response time could get affected with it. Or if it is a CPU, you could see an up to an 10% additional CPU required to process all these traces and send it to your APM in there. So I'm gonna send the chat in here. So that's the link to the documentation about the Open Telemetry module, and it does include the performance report. What kind, what were the parameters when we ran the report, so that you understand when I say 10% of the CPU increased, under what load, like what was the load on the API that we were testing, right? So it's all in the perspective of what is the load on the system. I hope that answers the question.
Does that help, Sridhar? Sudhir, yeah. Thank you.
Okay.
Okay, so next question is from Sudhir again. What are the best practices for exposing health check endpoints from security standpoint?
I think it's I wouldn't say use case basis, but it depends on what kind of systems you are interacting with. At the minimum, you would want to expose environment data like JVM information from your applications, right? And whatever the connect systems that you are interacting with, if you can expose the connectivity and connectivity times from that data. So it all depends what kind of systems you are using. I don't think there is a one standard best practice or the one standard set of rules that you can go. But at the minimum, that is what I would say. Put in the systems, and as you go ahead with that thing, and if you keep observing your data on dashboards, you can keep optimizing that and keep adding more things into that. I hope that answers. It's
Thank you, Manik. Yeah. Integration with pillars, the slide that you explained, there is a comment that it works fine with on-prem servers. How would
Mhm.
this, be mapped to Cloud Hub or VPCs?
I it should work same in both cases, because if I like go back to that slide in here, if it lets me, yeah. So if you see all of these things, all of this should work for the Cloud Hub and VPC too, right? Because Cloud Hub also sends all the metrics data to Anypoint monitoring, that is out of the box from the Anypoint platform, right? And the Anypoint Open Telemetry module works in Cloud Hub as well, so it can work in all of those deployment strategies that are supported for Mule application. Even for the logs, if you use log4j SQS appender, you are not logging into files as long as that SQS is reachable from your VPC or your Cloud Hub. Public Cloud Hub, it is reachable, but from VPC, if it is allowed to send data to SQS, you should be able to send that data to SQS. Logstash is residing into your AWS or outside of your platform, right? So as long as now Logstash can connect with the SQS, that should still work, right? And health check endpoints, if you set your networking correctly and make those health check endpoints accessible to Elasticsearch or the APM of your choice, that should also work. So none of these things is dependent on tied to on-prem itself. I hope that answers the question.
Thank you, Manik.
Mhm.
Uh, Another question is, won't this impact performance? Have you done any performance testing on this module? If you have any findings on that.
uh which module you mean? If it is about the Open Telemetry module, like I said, yes, we did a performance test, and if you take a look at that document link that I sent, towards the end of that documentation there is a performance report available there with all the observations and request performance test parameters. So that should give you an idea of what kind of performance impact it will have using this module, and under which conditions, like under which scenarios.
Okay,
and
and
i
in
think and i think that is standard, right? If you choose any monitoring tool or any monitoring framework, there is always going to be some performance overhead with all the monitoring tools.
yeah, and what is the option for companies who cannot send data outside their network? Do you have any solution for that?
I think there are so many other options available that you can deploy to your on-premise or in your data center, so that you don't have to go out. For example, Elastic Cloud, you can run Elastic on your in your data center, or on your on-premise servers. If it is not Elastic Cloud, like Splunk Enterprise, basically all those APM tools have an on-premise version of it. So you should be able to pick softwares which lets you install on your on-premise data center and not in the cloud.
Okay, thank you, Manik. One more
Mhm.
question. I think that's
Mhm.
the last question we have. It's from Kapil. He uses Wireshark for debugging issues,
Mhm.
and it's based on use cases. He's asking for any alternatives better than Wireshark.
I can't run it for 24 by 7. I mean, I doubt why would you run Wireshark 24/7. That's a lot of it. Wireshark should only be used for the debugging purpose, and when you are really trying to nail down something, it shouldn't be run 24/7. I'm not aware of anything alternative for Wireshark right now, because the level at which Wireshark gives you details, I haven't seen it any other tool. Maybe there are, but that's just something probably needs to be searched on the Google or researched. Sorry, I don't have on top of mind that one.
Uh, is there a way to get access to the slides? Suja, yes, the slides will on slide share and you can download a readable version of it, I believe. Right, Manik?
Yeah, yes, these slides and the recording will be available on the same event page there.
Okay, great. Uh, I think a couple is asking what is an option to, uh, what are the other options to use for debugging which don't impact much? When you say impact, couple, do you mean the performance impact or?
And I don't think that impact or that use of Wireshark has anything to do with the applications here. It is just debugging the network traffic and what is happening. So the kind of impact you may see there is network slowness because of Wireshark intercepting everything, right? And that anyways wouldn't have, probably shouldn't be done in the production for longer time. So I don't know what you can use instead of that right now, but maybe some research could show something.
Great. And Manik, one last question. What is
Mhm.
the supportability of this module? And how can the community contribute if there is any defects or something that they want to report on?
That would be awesome. Like I said, it's an open source module available on GitHub. If you can go, if you take a look at that, you will see already few issues reported by community, and we are fixing it. So it's open source. It will follow the same open source structure and same open source ethics. So any contribution, any issues, any kind of contribution is always appreciated, even if it is like an updating a document or reporting behavior that you have seen with a certain APM that you think could help others. So everything is appreciated, and you can always go to that repo and create issues in there, or if you want to fix something, it's always helpful. So it's open source. That's what I mean.
Awesome.
Yeah.
Thank you, Manik.
And
We
the
don't have any more questions, but yeah, feel free to add any comments.
Yeah, only one thing I would add into that is all those tools that I listed there, like custom logger or open telemetry module or the SQS appender, all of these are also published to the Maven Central. So it should be easy for you to just add a dependency in your Maven POM without having to configure any additional stuff into it. So Maven Central is always accessible. Hopefully, nobody's blocking that. But at least it will be proxied through your Nexus and all that. But all these are published to the Maven Central. That should simplify to pull into your environment.
Great. Okay, great. Thank you, Manik, for the great presentation.
Yep.
Yeah, this was very helpful, and I'm assuming everybody on that logged in found it very helpful. Uh,
Mhm.
Thank you, everyone, for joining. And for those who are not able to join, please check out the recording. It will be posted in another 24 hours. Uh, Thank you. Have a good rest of
Yep.
your week. Bye.
Thank you all. Thank you for listening. Thanks.